Today's lesson on fractions, we are learning about equivalent fractions. And here we're looking at these three diagrams. So the first diagram here, we have 1/4. Next diagram, if you look at the diagram, it's the same diagram as the first one, except it's been split into two horizontally, and it's now 2/8, but it's still the same as 1/4 and 2/8. And then if we cut it again, now we have 3/12. So all of those are equivalent fractions. All right, so those three diagrams and those three fractions represented equivalent fractions. All right, but we can write equivalent fractions without diagrams. We just have to multiply or divide the numerator and the denominator by the same numbers. Okay, so let me just write that out. So you're going to multiply, or you can divide I'm just going to say top and bottom, just so I don't have to write out numerator and denominator, by the same numbers. It has to be the same. By the same numbers. All right, so for example, we have 6/9 or 6/9. So we can multiply the top and bottom by the same numbers. Let's say we multiply the top and the bottom by 2. So that gives me 6 times 2, which is 12, and 9 times 2, which is 18. So 6/9 and 12/18 are equivalent fractions. We could have multiplied the 6, we could have multiplied by 5, and we could have multiplied the 9 by 5. Notice I'm multiplying the top and the bottom by the same numbers. So I could have gotten 30/45. That's still equivalent fractions. All right, now notice up here I said you can multiply or divide the top and bottom by the same numbers. So let's say we had 6/9, same fraction, and this time let's divide. Let's divide the top and bottom by 3. Again, I'm dividing by the same number. I'm dividing by 3. That will give me 2/3. All right, so 2/3 is still an equivalent fraction of 6/9. And next lesson, we'll learn about how we divided by the same number, and this is called a lowest terms or basic fraction. All right, so 8/12. Let's try that. I'll give you guys a moment to try that. All right, so doing an equivalent fraction for 8/12, I'm just going to multiply by 2. So I do have to multiply top and bottom by the same number. So that would give me 16/24. So that's an equivalent fraction. Then I also did ask you to do one division. So I'm going to divide by 4 because I'm able to divide the top and bottom by 4. And that gives me 2/3. So again, like I said, since we can't reduce this anymore, it is called a basic fraction, but we will look at that more next class. Okay, so next slide here, we have two diagrams, and we just have to name 2 equivalent fractions for each diagram. So the first fraction, obviously, we can just do the shaded. So 3/12. So 3/12 are shaded. And then giving an equivalent fraction, we can multiply or we can divide. I'm just going to go ahead and divide because I'm able to divide the top and bottom by 3. And that gives me 1/4. So 3/12 is equal to 1/4 or a quarter. All right, try the next one, please. All right, so for the next diagram, the shaded, we have 2/6. So 2/6 would be 1 fraction. And then we can reduce that, or we can multiply by another number, or we can divide. So let's just divide. We could divide by 2. Top and bottom has to be divided by the same number. So that gives me 1 over 3. 2 divided by 2 is 1, and 6 divided by 2 is 3. All right, so here we have to find the value of the missing component in order to make equivalent fractions. So we're looking for the missing variable here. So in this question, what would C be? So I'm just going to rewrite this out just so it looks more clear, like this, and we have to figure out the C here. So basically, how did we get from 9 to 36? Okay, so we multiplied by 4. 9 times 4 gives us 36. So therefore, we have to do the same thing to the top. We would have to multiply by 4. So therefore, this C here would equal to 20. So 5 times 4 is 20. So C is equal to 20. All right, so if I could erase this, I would erase this and put 20 right here. All right, so basically 5 over 9 is equal to 20 over 36. All right, for the next question then, I've just put a box here for y. So 3 times a number that gives me 36. So 3 times 12 gives me 36. So therefore, I would multiply 4 by 12 as well. All right, so 4 times 12, that gives me 48. All right, so I can just say at the end there that y is equal to 48. All right, so the next question, some of you have already completed it. So we are given 2/5, 2 over 5. 2 over 5, and we have to figure out P, Q, and R. So I'm just going to rewrite this out. 2 over 5 is equal to 4, and I'll just put a box there, and then over 15, and then 8 over R. All right, so when we're doing questions like this, always start with what's given. So we're given 2/5. All right, so starting with 2/5, how do we get to the 4? We would have to multiply by 2 to get to 4. So therefore, we're multiplying by 2 here to give me 10. All right, then we're going to use the same fraction. Start with 2/5. How do we get to 15? So 5 times 3 gives me 15. So therefore, I'm going to take the 2 and I'm going to multiply by 3, which gives me 6 over 15. All right, so we're going to do the same thing now again. Start with the 2/5. How do we get to 8? I'm just going to show that going over like this. We had to multiply by 4 to give me 8. 2 times 4. So therefore, we have to take the 5 and we're going to multiply it by 4, which gives me 20. All right, so we have completed those fractions there, but we'll keep in mind we did start with what we started with, which was 2/5. All right, so here in this slide, we're just deciding whether each pair of fractions are equivalent or not equivalent. So here we would say not equivalent, so no. All right, here 7 times 3 gives me 21. 8 times 3 gives me 24. So yes, this is equivalent. And then lastly, 1 over 4 and 3 over 8, is it equivalent? No, it's not. 1 times 3 is 3. 4 times 3 would be 12. So these are not equivalent. Okay, so lastly, our last slide here is showing that whole numbers can be expressed as fractions. So 4 over 1 is the same thing as 4 divided by 1, which equals to 4. 8 over 2, that's the same thing as 8 divided by 2, which is equal to 4. 12 over 3, which is 12 divided by 3, it's equal to 4. 16 divided by 4 also gives us 4. So we can write whole numbers as fractions because fractions are technically another way of writing division. So if we had the number 12, list 3 fractional numbers for each of the following whole numbers. So the first one we could say is 12 over 1. That gives me 12. Another one, we could say 24 divided by 2 would also give me a 12. All right, and another one would be 36 over 3, right? Because 36 divided by 3 is equal to 12. And then, yes, 48 divided by 4 would be another one. Yeah, so that would be another one. All right, so this is just showing again that fractional numbers can be written for whole numbers. Just keep in mind fractions also represent division. All right, so for number 9, the first one, 9 divided by 1 gives me 9. Another one, would be 18 over 2, because 18 divided by 2 gives me 9. And one more, 27 over 3. Oh. All right, because 27 divided by 3 does equal to 9. All right, so we'll stop there for today. The homework will be on the message board.